Alright, looking at question 19, this is asking us to use lines of reflectional symmetry, which we did not talk much about, but when we're looking at a hexagon, it has 6 equal sides. 1, 2, 3, 4, 5, 6. They're all of equal length, so we actually get a lot of lines of symmetry. For example, we can go straight down the middle right here. We can also go straight down the middle right here. Straight down the middle here. We can also cut it to their vertices, like so. This vertex here. Notice they all get pinned in the middle if we do this right. Cool. So it says describe the rotations that will carry it onto itself. So we know that if we did a 180-degree rotation, you can see clearly if we rotated this 180 degrees, it would carry it onto itself. We can also go from here to here is 1/3 of 180, which is 60 degrees. So we got 180 degrees, we got 60 degrees. It's another one. It looks like 2/3, that's 120. And then if we're looking at these, let's go on purple. Rotations like this, right? How many times is this? It's 1, 2, 3, 4, 5, 6. So 1/6 of 180 is also 60 degrees. So we have all those ways we can rotate it. Draw the lines of reflection symmetry for the, it says hexagon. I think it's referring to this star. So I think we have fewer. We can't go like this, that won't work. That's not a line of symmetry. We can though cut it here. Cut it here. And right here. And finally right here. Okay. And so the rotations that will carry it onto itself would be, looks like we can go, if we took this point and went to this point, that would work. And that is 1/3 of 180, which is 60. We can also go from this point to here, which is 2/3 of 180, which is a multiple of 60. From here to here, that looks like it's also 60 degrees, because that is 1. We can rotate this. What would this be? That's 180, and this is 1, 2, 3, 4, 5. So 2/5 of 180 as well. What would 2/5 of 180 be? $72 degrees. Okay. And then just multiples of 72 degrees that go up to 180. Alright, those are questions you don't have to worry too much about. They might be on your second part of your final, the district final. This says solve the for x in each figure. So as you look here, you see these lines are parallel, and therefore when you're looking at these two angles, you know that they are corresponding angles, and we know that corresponding angles are congruent. Okay, so you can set up this equation and then solve for x. When you're looking at these two lines, we actually don't know they're parallel. These should have this going on here. Otherwise, I would write not enough information to determine, but let's assume they're parallel. In this case, looking at these two, we know that they're same side exterior, which we know same side, supplementary. Okay, please try to remember that. Same side, supplementary. So if they're supplementary, we know that they add up to 180 degrees. So you can solve from there. Nice, 25. There you go. It's just asking to solve for x, so we don't need to plug that value back in. Use the figure to determine the measure of each indicated angle. Okay, so EGA is this angle here. And then I'm also going to look here at FHC or CHF. Notice they're same side exterior, therefore they must be same side supplementary. So they add up to 180. Combine like terms. Subtract 4 from both sides. $176 divided by 16. That would be 11. Yeah. So since x equals 11, now we'll actually have to plug this value in. So for this one, we would get 55. And I don't even have to plug in x here. If I know this is 55 and this is supplementary to 55, we know this is 125. Okay, and since we know those two angles, we can figure out all the rest. Given that these lines are parallel, they didn't show these lines are parallel. These should be parallel, or else there's no point. Okay, so this is 125. This is 55, this is 125, this is 125, this is 55, this is 55. Can you see it? Let's make these blue. Okay. So, it's probably the easiest way to do it. Then you can just name them after this. This is 125. CHF, that's 55. FHD is 125. EGB, 55. Okay. In the diagram, BC bisects angle ACD and J is parallel to K. Find the value of W. Alright, good. This is actually one we had on one of our tests. So, they're saying that this bisects this angle here, ACD, which means it cuts it into two equal parts. So we know that 72 plus, we'll say 2x, we could just call these both x, equals 180. So 2x is equal to 108. And then we get x is equal to 54. So this must be 54. And this must be 54. And we actually know that these two angles here are congruent. since they're corresponding angles. If you just look at these lines being parallel in the red transversal, you'll see these are corresponding. Okay, so we can write the following equation. Subtract 80 from both sides. Negative 13. Now you might be like, oh, it's a negative. We don't get negative angles. We'll plug it back in. So you get 2 times negative 13 plus 80. We get negative 26 plus 80 equals 54. Yeah, good, it makes sense. So W equals negative 13. Cool, we still got time. Find the value of x that makes J parallel to K. Okay, so if these are parallel, then these would be corresponding angles that are congruent. So we can say 3x plus 3 equals, what is this, 129. Subtract 3 from both sides. That would mean this needs to be 42.